Hi all, this is going to be day 2 of your Unit 4. So you want to go to Unit 4 Notes, day 2. And we are going to be talking about solving systems of equations today algebraically. Specifically, we're going to talk about solving 2 variable systems, and then eventually we're going to get up to 3 variable systems. So if you see, I'm hoping you'll see this document, you can do the do now. The do now is about solving graphically, which is something we did on Friday's lesson. And underneath, it says watch the video and look at the notes below. So there are 2 ways to solve a system algebraically. The 2 ways to solve the system algebraically are we can either use elimination or we can use substitution. And you have seen these back in Algebra 1. We're going to start first with elimination. The goal of elimination is to get blank for one of the variables so they will cancel out. So you want to eventually get 0. You want to basically get the same variable, one positive and one negative, which are called additive inverses for one variable, so it will cancel out. So what do I mean by additive inverses? Well, let's say I have 3x. The additive inverse of that would be negative 3x. So if I add 3x plus negative 3x, those are going to cancel out, and I'm going to get 0. Let's say I have negative 2y, then the additive inverse would be positive 2y. And when I add those together, I'm going to get 0. Let's say I had c, the additive inverse would be negative c. So then when I add them together, I'm going to get 0. So basically you want the coefficients to be the same, 3, 3, 2, 2, 1, 1, but one positive and one negative. So when you add them, you'll get 0, and you'll basically cancel out one of the variables, and you'll be all in terms of the other one. You have actually seen this before. So let's take a look at this first example here. So notice that this is structured so that the x's are underneath each other, the y's are underneath each other, and then the constant is on the other side of the equal sign. So we lined this up on purpose so that way you could see that there is a chance of doing elimination. We see we have negative y and positive y. So negative y and positive y are called additive inverse because one's positive, one's negative. So we can actually add these 2 equations together and look and see what happens. So when you add these x's together, you get 2x plus 1x, which is 3x. And then when you add these negative y and positive y, they cancel out. So you just get 0 for the y. So you don't even have to write it. And then you get equals, and then 2 plus 2, 4. So notice I'm just adding down the column. And notice we have eliminated the y variable, so now I am just stuck with x, so now I'm just going to solve for x. So I'm going to divide by 3, and I get x equals 4/3. Now the thing is that we talked about on Friday, a system, you need both x and y coordinates for the answer. So right now I only have x, I have to go get y. So the way to get y is you can decide which equation you want to substitute in and solve for the other variable. I'm going to use the easier equation, so this is equation 1 and equation 2. I'm going to use equation 2, x plus y equals 2, because I think it's a little easier. You're going to substitute in this x value, x equals 4/3 in for x, and you're going to solve for y. Okay, so let's subtract 4/3. Subtract 4/3, and we get y equals 2 minus 4/3. So let's say you're not good at fractions. Remember, you can use your calculator. 2 minus alpha y equals 4/3. And you're going to get 2/3. Okay, so remember, sometimes it's helpful to use your calculator. So now we have an x and a y. So our final answer, remember, is a coordinate pair, x and y, if it's a system, because we need x and y together, working together to get an answer. So this is x first and y second. Now just keep in mind we can check our answer if we wanted to in the other equation that we didn't use. So our other equation was 2x minus y equals 2. If we plug in the coordinates that we just obtained for x and y, we should get the answer of 2. So 2, let's plug in x equals 4/3. And let's plug in y equals 2/3, and we should get an answer of 2. So let's see, let me minimize this. Here we go. 2 times parentheses alpha y equals 4/3, close parentheses, minus, open parentheses, 2/3, close parentheses, and see if you get 2. And we do, equals 2, check. So 2 equals 2, check. So we know we're good. So the answer can be written as a coordinate pair. It can be put in a solution set as well, like this. But notice we have x and y. All right, let's try another example. Here we go. Number 2. Okay, first advice is stack these two systems on top of each other. So c minus 2d equals 14, and we'll do c plus 3d equals 9. Now, in this case, we don't have additive inverses because if I added these, the c's would not cancel out in their current state. We have c and c, right? C plus c is not 0, it's 2c. So what I want to do is manufacture additive inverses by multiplying one of these rows by, in this case, -1. So it's up to you which one you want to do. I'll maybe multiply the second row, equation 2. I'll call this equation 1 and equation 2. I'll do multiply equation 2 by -1. But remember, when you multiply it by -1, you got to multiply all the terms by -1, okay? So let me put, I'll do in blue here. I'm going to show you that I'm going to multiply by -1. So I'm going to rewrite this so you can see c minus 2d equals 14. The first one remained the same. But now the second equation is going to become -c, -3d, and -9. Notice I have to distribute the negative to all three terms. 1, 2, 3. Even the one on the right side of the equal sign. So now I'm ready to add and go down the column. So I have c plus -c cancels because that's your additive inverses right here that we created. And now you're going to add down the next column. -2d plus -3d is -5d. And 14 plus -9 is +5. And lastly, we're going to divide by -5 to get d by itself. So we get d equals -1. So that's one of my coordinate pair. All right. But now the next thing I have to do is, again, I have to solve for the other variable, which is c. So I'm going to go to the easier equation, which in my opinion, it was equation 2. c plus 3d equals 9. And I'm going to plug in the d equals -1. So I'm going to do c plus 3 times -1. And I'm going to solve for c. So this is the step where you're going to solve for the other variable, in this case c. Okay. All right, so c plus -3 equals 9. Add 3, we get 12. So we get c equals 12. So remember, our answer should be a coordinate pair. It's going to be c comma d if we're treating them in alphabetical order. So we'll do 12 comma -1, c, d. Now we're going to check our work in the other equation to make sure we did it right. So when you check, you're going to go to the other equation that you didn't use to solve for c. So I'll do equation 1, which was c minus 2d equals 14. Go plug in 12. Plug in -1 and see if you obtain 14. I'm going to get 12 plus 2, which is 14. And I'm good to go. So there you go. There's equation number 2. Now we're going to pick it up a notch and get a little bit more challenging, I guess you could say, in that it's the elimination is not as obvious. So if you look at example 3 now, you see at first glance we see nothing really will cancel out because you don't have any additive inverses at all. So we have to manufacture something that's going to be an additive inverse. It's basically like a least common multiple of one of the variables. So I'm going to choose x. And what I'm going to do is I'm going to multiply the first row by 4, and I'm going to multiply the second row by 3, so it will be 12 and 12. But I'm going to multiply the second row by -3 instead of +3 because I want one to be positive and one to be negative. So my advice to get the least common multiple is just, if you're not sure, you can just multiply the two together. and you get 12. So basically one of them is going to become positive 12 and the other one is going to become negative 12. So now I'm going to distribute to my first row. I'm going to get 12x plus 8y equals 16. Notice I'm distributing the 4 to all three terms. 1, 2, 3. 12x plus 8y equals 16. So that's row 1. Now I'm going to do row 2. Distribute the negative 3. Negative 12x, negative 21y, negative 3. And now I'm going to add, and I'm going to see that I have positive 12x in the first row and negative 12x in the second row. And those are your additive inverses that I created, and they're going to cancel out. I could have chosen to do 2 and 7y instead. I would have multiplied the first one by 7 and the second one by 2 or negative 2. It's up to you which one you want to cancel. I just chose x because it was first. So whatever you want to do. So now these are going to cancel out because 12x plus negative 12x equals 0. Now you're going to add 8 plus negative 21, and then you're going to add 16 plus negative 3, okay? So make sure that we add this all up. So as you can see, I added down the first column here, 8 plus negative 21, I got negative 13. Second one, I added 16 plus negative 3, I got 13, and then I divided, and I got y equals negative 1. Now I'm going to go plug in to solve for x. So I get 3x plus 2y equals 4. I'm going to plug in y equals negative 1, and I'm going to solve for x. Okay, so I got x equals 2. So now we're going to check it into our other equation. So our second equation was 4x plus 7y equals 1. So plug in to check. So as we can see, it did check out. I just plugged it in on the side here, and I got the answer. So there you go. So our final answer, let's write it as a coordinate pair, x comma y. 2 comma negative 1. Okay, so graphically, what does this mean? We didn't really talk about this, but because these are two lines, this would mean that the two lines intersected, and they intersected specifically at this point, which is called the point of intersection. So we did talk about the point of intersection graphically on Friday. The next type of solving is called substitution. I'm hoping you guys have seen this before. So I'm actually going to revisit example 1 that we just did. We already know the example answer to example 1 is 4/3 comma 2/3. So keep that in mind. The answer should be 4/3 comma 2/3 when we do this. I'm just telling you that from the beginning, okay? So substitution. So basically to substitute, if you look below, we have some steps here. It says isolate one of the variables in one of the equations. I would recommend going to the easier equation of the two and trying to solve for one of the variables. So I'll call this variable equation 1 and equation 2. Maybe I want to solve for y on equation 2. So I'll subtract x, and I'll get y equals 2 minus x. So I just did step 1. I isolated one of the variables. Now step 2, so we did this one. Substitute into the other equation for this variable. So it will only now be in terms of 1. So I'm going to go back to equation 1, which is right here. And in equation 1, it was 2x minus y equals 2. I'm going to change it to 2x minus, instead of y, I'm going to plug in what y equals, which is 2 minus x. So there's your substitution step. If you look from line 1 to line 2, instead of 2x minus y equals 2, I wrote 2x minus 2 minus x equals 2. So now I'm going to distribute. 2x minus 2 plus x equals 2. So I'm going to get 2x plus 1x, 3x, minus 2 equals 2. Then I'm going to add the 2 to solve for x. So I get 3x equals 4, divide by 3. I'm going to get x equals 4/3, which I told you we would get. So we just did step 2 and 3. we substituted and we solved for the one variable. So we got x equals 4/3. So just like the other process that we did before, now we have to substitute this value into the easier equation and solve for the other variable. Solve for the other variable, okay? So I'm going to go to the other equation, which was equation 2, x plus y equals 2, and I'm going to solve for y now. X plus, sorry, I got to solve for y. X was 4/3, y, we don't know, equals 2. Subtract 4/3, subtract 4/3. And again, if you need the calculator, you can, but you know the answer should be 2/3 for y, okay? So our final answer is the same, which is up here, 4/3, comma 2/3. So there's the substitution method. And basically the substitution method, you can do it for all of these as well. So now if we look at example 2, so some of these gear themselves more towards substitution and some of them gear themselves more to elimination. And some of them it's up to you. Some of them it doesn't matter. So if you look at example 2, maybe it's easier to solve for C for either of these. It's up to you. So maybe I'll go to equation 1 here and I'm going to solve for C. So I'll add the 2D. And I'll get C equals 2D plus 14. And then I'm going to go to equation 2, and I'm going to plug in for C 2D plus 14. So I'm going to do 2D plus 14 plus 3D equals 9. Okay, so I replace C with 2D plus 14 because it was C plus 3D equals 9, and now it's become 2D plus 14 plus 3D equals 9. So now we're all in terms of D. So I have 2D plus 3D. Those are like terms. So I get 5D plus 14 equals 9. And now I'm going to solve for D. I'm going to get D equals -1. And then I just go back to my other equation. I'll just use the second equation for now. Equation 2. And plug in D equals -1 and solve for C. So I got 12. So C comma D should be 12 comma -1. Final answer. And then I would check it in the other equation, but I already did that earlier. So let's just make sure I got the right answer, 12 and -1. So looking back, oh, I did. I got 12 and -1 right here. And here it is again, 12 and -1. Okay, so basically now underneath here we have a bunch of examples, and you can choose to do either method you prefer, and whatever you think is easier is what you're going to do.